In this video, we will be discussing on the topic of cipher block chaining. CBC is known as cipher block chaining. This is a block cipher where a sequence of bits are encrypted as a single unit or block and a cipher key is used on the entire block. Cipher block chaining uses an initialization vector, IV, of a certain length. A key characteristic of CBC is that it uses a chaining mechanism that causes the decryption of a block of cipher to depend on all the preceding cipher text block. As a result, the entire validity of all preceding blocks is contained in the immediately previous cipher text block. In CBC mode, each block of plain text is XO-read with the previous cipher text block before being encrypted. This way, each cipher text block depends on all plain text blocks processed up to that point. To make each message unique, an initialization vector, IV, must be used in the first block. The IV here does not have to be kept secret, but it can be encrypted. However, it is useful to not reuse the IV. Here we see the plain text split into a few parts. The first plain text is XO-read with the IV as there is no previous cipher text to be used since it is the initial plain text. From here we encrypt it with a block cipher encryption using a key which then produces the first cipher text. An example of a block cipher that can be used is AES or DES. This process is then repeated with the second plain text, but instead of using the initialization vector, this time we use a previous cipher text block to carry out the encryption as seen in the video. The same process is repeated and it will produce cipher text 2. This process is repeated for the remaining number of plain text blocks. A single bit error in the cipher text block can affect the subsequent block's encryption, and the rearrangement of the order of the cipher text blocks can cause decryption to be corrupted. Note that the plain text block and IV should all be of the same size, for example 64 bits. For decryption, cipher texts are split in the form of 64 bits. The first block of the cipher text is decrypted with the same encryption standard used for encryption. The same key used for encryption earlier will be used to decrypt. The initialization vector is the same size as the cipher text, 64 bits. The first cipher text uses in the same initialization vector used when it was encrypted and carry on to use the XOR operation, which will result in the first block of plain text. The following cipher block is first decrypted with the same key, the same process from the first cipher block. The first cipher block will act as the initialization vector, which then be XORed to get the plain text. The previous cipher text will be used as the initial vector for the next process. For example, the cipher text 1 will be the initial vector for the decryption process of cipher text 2. Carry on to compare using the XOR operation to produce the plain text. The whole process will be repeated until the end of the cipher blocks. After getting all the plain text block, the blocks will then be combined and in result getting the final plain text. Thanks for watching.